Welcome back. All right, so today's lesson, I am gone. So I was gonna go ahead and record this for you guys. So you guys had all the notes you needed. You can watch it back as many times as you want. If you have anything that doesn't make sense, you can rewatch it, slow it down, speed it up, whatever you want, okay? If you have questions, come see me before school, after school, during ACE. But let's get started. So we have done inequalities this entire unit. But what we're doing today, we're gonna do absolute value. So in order to understand absolute value, we're going to do equations first. Absolute value equations, and then we're going to talk about absolute value inequalities. Okay? So, first off, absolute value. What is it? The definition of absolute value it is a number's distance from zero. Okay, a number's distance from zero. That is absolute value. So, absolute value, what does it look like? Absolute value are these two bars. Okay, so if I had a number in the middle, -2. This is called the absolute value of -2. So, how far is -2 from zero on a number line? Well, if I have a number line, 1, 2, -2. So, how many spots is it from 2? 1, 2. So the absolute value of -2 is just 2. Okay? There is no negative or positive with absolute value. Everything is strictly positive. Okay? So the absolute value of -2 is 2. The absolute value of positive 2, again, 1, 2. How far is it from 0? 1, 2. It's simply 2. Okay? That is absolute value. It is at the most basic form how far a number is from 0. Okay, so let's do a couple and make sure we got this down before we go any further. So the absolute value of x equals 5. So what can I plug in here for x that would equal 5 as an absolute value? Well, you'd say 5, because if I take the absolute value of 5 is 5 spots from 0. So, therefore, my absolute value of 5 is 5. So, I get x equals 5. But it doesn't stop there. Because what else is 5 spots from 0? The absolute value of -5. -5 is also 5 spots from 0. So my answer is x equals 5, x equals -5. I have two answers. That's how absolute value works. Okay? So, now we're going to talk about absolute value equations. Absolute value equations doesn't change anything. Absolute value bars operate just like parentheses, brackets, braces, and then the fourth one is absolute value bars. Those four are called grouping symbols. You treat them just like you would any other grouping symbol. Parentheses, braces, brackets, doesn't matter. So you're going to treat an absolute value equation just like any other equation. So if I have 2 absolute value of n plus 2 equals 8, I have to treat this as if this looks like this. Okay, so if I had this, what's the first thing I would do? Well, we always have to try and get n by itself. So this is one term, basically. So I have to get rid of this second term. So I have to subtract 2. So I'm going to go ahead and subtract 2. Okay, so again, I just drew this to show you that this looks like this. You treat them the same way. So I subtract 2 from both sides. My 2's cancel out. I'm left with 2 absolute value of n equals 6. So now what do I have to do to get n by itself? I have to divide by 2. Okay, so now what I'm left with is the absolute value of n equals 3. So this is just like the other one, where we had absolute value of x equals 5. So what is 3 spots away from 0? What two numbers are 3 spots away from 0? Well, n equals 3, because if I take the absolute value of 3, it would be 3. And if I take the absolute value of negative 3, I would get 3. So my answer is n equals negative 3 and 3. Okay, that is how we do an absolute value equation. We treat the absolute value bars just like you would parentheses, brackets, braces, and then I just solve for the variable. So if I do that, that is how this is going to work. I simply just break it down just like I would any other equation. Okay, so let's do another one. Okay, so negative 2, absolute value, 2n plus 5 equals negative 22. Okay, so this one's different, and I'm going to show you how. This, remember, we treat just like parentheses. So I can't subtract 5 from it because it's still within the bars. So how do I get rid of the bars? Well, first I got to get rid of my leading coefficient. So I just have to divide by negative 2. Okay, so my new equation is absolute value of 2n plus 5 equals 11, because my negative 22 divided by negative 2 is going to cancel out. So, forgot the other absolute value bar. Okay, so how do I solve this? It's pretty easy. I just break it up into two equations. My first equation is 2n plus 5 equals negative 11. My other one is 2n plus 5 equals positive 11. So I just take what it's equal to and I set it to two different numbers, a positive form and a negative form. And then I solve. So I subtract 5 from this side. Negative 11 minus 5 is negative 16. 2n is what I have left. I divide both sides by 2. 2's cancel out. I'm left with n equals negative 8. There's one answer. Then I have to solve the other equation. Subtract 5. Cancels out. 2n, 11 minus 5 is 6. Divide both sides by 2. N equals positive 3. That is how you solve it. The difference between having to write two equations and just solving it normally is if your variable is by itself. So if you look at your notes, last problem that we just did, the n was by itself. So we didn't have to break it up into two equations and put it as set it equal to two different values. You just did it regularly. But if you have a variable that is not by itself in absolute value bars, that is when you have to break it up into two separate equations that equal two different values, a positive value and a negative value. Okay? Two examples, and then we're done with this section of notes. There's going to be a part 2, and it will all be in this one video. Okay. Negative 5, absolute value, x plus 1 plus 2 equals 12. Okay, from here, it's pretty straightforward. Remember, just like grouping symbols or parentheses, we leave this alone for now. I have to get it by itself, so I'm going to subtract 2. I'm left with negative 5, x plus 1 equals 10. Okay, how do I get this by itself? I have to divide by negative 5. Okay, now I'm left with x plus, absolute value of x plus 1 equals negative 2. So, is my x by itself? No. So I have to break it up into two separate equations. Okay, so I have x plus 1 equals negative 2, and x plus 1 equals 2. So let's solve for x. Minus 1 cancels out. X equals negative 3. Okay, there's one answer. Come over here and subtract 1. Cancels out. X equals 1. Okay, so we're done solving. But you can always check your answer, so let's check it. 1 plus 1, 2. Absolute value of 2, so how far is 2 from 0? It's 2. So negative 5 times 2 is negative 10. Negative 10 plus 2 is negative 8. Wait a minute. Negative 8 doesn't equal 12. Let's check the other one. Negative 3. Negative 3 plus 1 is negative 2. The absolute value of negative 2 is positive 2. So negative 5 times positive 2 is negative 10. Negative 10 plus 8 is negative 8. We got negative 8 again. But negative 8 does not equal positive 12. So what do you think that means? I'll tell you. We did not make a mistake. We did everything right. It just happens to not be true. There are no solutions. So your answer here, no solution. There is no number that can make this equation true. Okay? So be aware of that. Be aware that there is a problem on your homework that has no solution on it. Okay? We have to be paying attention because sometimes you're going to get an answer, you're going to think, oh, I'm done. Just check it real quick. That took me 30 seconds to check 2 answers. Okay? So you can't have no solution. Let's do one last example for this section. All right. Equation number 2. Technically I guess this would be like 4, but okay, here we go. 3/5. Yeah, I'm throwing a fraction at you. 3/5 absolute value. 2x minus 4. Minus 3 equals 3. Okay, so let's solve. How do I get well, first off, we need to get rid of this. Because remember, we always add and subtract first. So, add 3, cancels out. Add 3, 3/5, 2x. Yeah. Oh, this is negative 3. My bad. Negative 3. So, 2x minus 4 equals negative 3 plus 3 is 0. Okay. So, now I need to get my grouping symbol by itself. So, how do I get rid of a fraction being multiplied? I multiply by the reciprocal. The reciprocal of 3/5. 5/3. This cancels out. I come over here, multiply 0 by 5/3. Guess what 0 times 5/3 is? 0. So my new equation, absolute value 2x minus 4 equals 0. Okay, now we just set it up in 2 equations to solve. So I get 2x minus 4 equals 0. And guess what? 2x minus 4 equals 0. These are the same equation. There is no negative, positive, 0. 0 is a neutral value. It has no positive or negative. So I only need one equation. So I'm just going to go ahead and erase this. They're the same thing. I don't need 2 of the same thing. So let's solve. Add 4 to both sides. 2x equals 4. 2's cancel out. 4 divided by 2 is 2. Okay, here's my answer. We should probably check it now that we know there can be no solutions. 2, plug in 2 for x. 2 times 2 is 4. 4 minus 4 is 0. Well, the absolute value of 0 is 0. 3/5 times 0 is 0. 0 minus 3 is negative 3. Well, that's what we get. All right. So that is a true solution. Sometimes you can only have one answer. Sometimes you'll have no answers. Sometimes you'll have 2 answers. Okay? So just be aware that there is going to be a chance here and there where you only have 1 answer or 2 answers or no answers. All right? So that's the end of the first part of this video. I'll be right back with part 2. We're going to talk about inequalities. It shouldn't take as long as this first part, and that'll be it. All right? See you in a second. All right, part 2, inequalities. So on this one, if you are from one of my other classes that isn't 4B, listen to this because I didn't tell you this, I forgot to mention it. Everyone else in my 4B, just go ahead, this is your regular lesson, regular notes. Okay, so for solving absolute value inequalities, if the absolute value is less than B, or it could be less than or equal to, it follows the same rules. So if the absolute value is less than B, you solve it as a compound inequality where A is greater than negative B and it's less than B, positive B, okay? So if I had this equation and this was like a negative, and this was a positive 6, so the absolute value of X is less than 6, I would solve so that I have A is less than 6 and A is greater than negative 6. And it would look something, I'll just show you in a second. Okay, if the absolute value of A is greater than or equal to B, again, they follow the same rules, then you solve it for A is less than the absolute, or A is less than negative B, or A is greater than B, okay? So this is where those compound inequality rules come from. So let's do one. We're going to do the absolute value of V minus 3. Actually, let me switch colors so it doesn't look like the notes. Absolute value V minus 3 is greater than or equal to 4. Okay, so looking at this rule, it says A is greater than B. So I'm going to solve it like I would here. So I'm going to have two equations. I'm going to have V minus 3 is greater than or equal to 4. Okay, so I have that part. But I also need V minus 3 is less than or equal to negative 4. It's hard to read. Let me rewrite that. Okay, so V minus 3 is greater than or equal to 4, which is basically the same thing as this. I just took away the absolute value bars. And then the opposite, where I had to flip the sign and flip 4 to a negative value. So, if I were to solve this, I would add 3 to both sides. These would cancel out. I'd be left with V equals 4 plus, or not equals, is greater than or equal to 4 plus 3 is 7. See? So I got 7 or higher. If I were to do this one, I would get minus 3 or plus 3. And what I would be left with is V is less than or equal to negative 1. So those are my two answers. So if I were to graph this, let me get a better color. If I were to graph this with blue, 0, negative 1, 2, 3, 4, 5, negative 1, 2, or positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's really long hashes. Okay, so if I were to map this, I would have one value at 7 filled in because it's greater than or equal to. And it is greater than 7, so it's going to go this way infinitely. And this one I would start at negative 1. And I would go this way infinitely. Okay? So that's what that would look like. Okay? But here's the difference. If I were to do this, and I flipped this sign to here, now things change. Okay? So, A is less than or equal to B, absolute value. So I have to solve it like this. So, if I were to write this, I would have drop the absolute value bars, V minus 3 is greater than or equal to negative b, and I would have v minus 3 is less than positive 4. So let's solve. Add 3 to both sides. Add 3 to both sides. 7. V is greater than or equal to 7. Okay. Oh, I forgot the negative sign. That's why. Hold up. Negative 4. Remember? Greater than negative b. So negative 4. So if I were to add 3 here, I get negative 1. Okay? So v is greater than or equal to negative 1. If I add 3 over here, I get v is less than or equal to 7. So that changes things. We got the same values, but if I were to graph this, what would it look like? Well, okay, so here's my negative 5. So if I were to plot this, I'd have negative 1, and I'd fill it in. And I'd have positive 7, and I'd fill it in. Okay, but which way are they going? Well, 7 is greater than or equal to v. V is less than or equal to 7. So I would have to go this way. And I can't go forever because this is a compounding inequality where it has to satisfy both options. So it also has to be greater than or equal to negative 1. So it is simply filling in the space between. Okay, so hopefully that makes sense. If you're in one of my other classes, I'm sorry, I forgot to mention this during class. I dropped my marker cap somewhere. But anyways, that is the gist of how to do this. Okay, if there was a number outside here or here, you treat it just like you did with any equations. Okay, nothing changes with that regard. You could put a 2 here, and it just means the first thing I would have to do is divide both sides by 2. And then I would do this step that we just did. Okay? Oh, found the cap. So, if you have any questions, please come see me tomorrow, Friday, in ACE, or before school, or after school, and I will get you lined out. Okay? That is the gist of today's lesson. Hopefully, I know you guys are going to think it's hard and confusing, but we'll get through it. All right? Have a good one. Thanks. See ya.